Welcome. The following video will cover the main aspects and requirements of a thorough life cycle assessment study. The first step is defining the project requirements and boundaries. For this, design conditions such as purpose and use, loads, or climate-related requirements must be well defined. Likewise, the structure service life must be set. If we are talking about, for example, a comparison between an asphalt and a concrete road, the maintenance and replacement during the life cycle will have a significant impact over the environmental results. Once the project requirements and boundaries are set, a functional unit must be defined. The functional unit serves as the basic unit of the project, used for the life cycle inventory and LCA calculations. Again, for our road project example, the functional unit could be defined as 1 kilometer of road, with set geometric characteristics, located in a specific location, for a given service life, with defined traffic conditions. With the functional unit defined, we can proceed to construct a lifecycle inventory. Inventories must be defined for all compared solutions, which should be technically equivalent in the way they solve the analysis problem. A proper lifecycle inventory must include all materials and construction processes, together with transport-related activities and energy consumptions. Within the functional unit, it must also be defined which stages of the life cycle will be covered. Based on various European standards, we can define stages from A1 to A5, B1 to B4, and C1 to C4. A stages cover the raw material extraction and energy generation, transportation from manufacturer to construction site, and construction activities. These stages are usually referred to as cradle to gate. B stages cover the service and maintenance of the structure throughout its service life. Finally, C stages cover demolition and deconstruction, waste transportation and treatment, as well as any material recycling. If all stages are considered, the analysis is usually referred to as cradle to grave. Let's take the example of a road foundation stabilization. Considering a fixed road geometry and load conditions, we could consider first a standard road stabilization with granular material. Second, a reduced granular layer placed atop a geogrid layer. And third, a reduced granular layer placed atop a stabilized layer with lime extracted from the construction site. Once all alternatives are defined, we can now proceed to define the life cycle inventory and evaluate the environmental impact. If a cradle-to-grave analysis is to be done, the life cycle inventory must include all materials, transportations, and equipment required in the operation and maintenance of the structure, as well as the demolition, transportation, and processing of the waste and recycled materials. The following videos will continue to cover the LCA study process.